Welcome to today's presentation on high performance backup and restore with MinIO and Veeam. All attendees are on mute. We will take questions via the chat window, so please ask them as the webinar progresses, and we'll answer them all at the end. Today's presenters are Echo Willson of MinIO and Steve Firms of Veeam. Echo is a support engineer with MinIO. He came to MinIO from Gluster and Red Hat. And Steve is a solution architect with Veeam, where he specializes in object storage, and he spent his entire career in the field of data protection. So without further ado, I'm going to turn it over to Echo to get us started. And again, we look forward to seeing your questions in the chat window.
So hello, everybody. My name is Echo Willson. Like Jonathan said, I'm support engineer at MinIO. Today we'll be talking about high performance backup and restore with MinIO and Veeam. So everybody on this webinar knows the importance of backup and recovery. It's your process, your people and technology that are the core components of that plan. But in today's world, that's not enough. So ransomware is a nasty business and everybody's at risk. I think just in the past week, we've seen high profile cases from Equinix, DXP, GAM, Tower Semi, and some others. And this is just a fraction of the overall list because it's only the publicly disclosed events. So there were 121 million attacks in the first half of 2020, which equates to one about every 14 seconds. These attacks are happening against billion-dollar companies with thousands of employees and massive budgets for cybersecurity. So the ransomware game has evolved so rapidly that it's difficult to keep pace. First of all, it's a pay-to-play enterprise. If you're not successful as an attacker, you don't get paid. It's as simple as that. As a result, attackers are going to choose their victims carefully and exploit their weaknesses broadly, and do that with incredible speed. They know exactly what to do, and they're just waiting for a chance to get in. Second, as it's become more lucrative, it's become a team sport. There are literally live rankings of the most successful ransomware shops out there. And third, while you have to start with defense, you also need a great recovery plan. So we're going to discuss both concepts today, immutable backups and rapid restore. So immutable backups and rapid restore are going to matter because ransomware isn't going to stop when the attack is foiled or the ransom's paid. If you're down for a few hours or a few days, you're going to lose that revenue and productivity. But on top of that, you're going to lose the confidence of your stakeholders. And this is hard to win back. Having a shorter downtime and no downtime at all is going to mitigate that risk. Second, you're going to have to spend to defend. There's no way around that. So designing immutable systems is a cost that you can think of as a tax that's being imposed by the ransomware. And whether you choose Veeam and MinIO or someone else, don't skimp because you don't want it to be a career-limiting move. And third, you have to attack complexity in silos. So think of this as a tax as well. It takes time and effort and good design to make immutable backups part of the fabric of your organization. So keeping things simple is going to assure adoption of that process. So if there's a silver bullet to all of this, it's immutability. And immutability is the guarantee that your data, in this case, the objects being backed up to object storage, can't be changed. That means they can't be deleted, they can't be modified, they can't be encrypted or have any other action happen to them, full stop. Immutability must, however, be kept simple. If it is, that becomes part of the fabric, and if it's not, it just becomes a weakness to be exploited. Finally, immutability isn't a marketing feature. It needs to be validated by third parties, and if it isn't, you should be worried because it has to work every time, all the time, otherwise you're going to be a sitting duck. So here, let's talk a little bit about the architecture of Veeam and MinIO together and how they give that high performance and validated immutability. So it's going to start off with source data. In this case, we're talking about virtual machines, but that could extend to databases or applications or anything else that Veeam can protect with immutability. That data is going to be packed up to the performance tier on Veeam, and then older copies can either be moved out to the capacity tier, or you can make immediate copies of the data that's in the performance tier, backing it up to the capacity tier. So the capacity tier is generally going to be object storage, and the reason for this is scalability. Object storage can easily grow to many petabytes, so this data has to be rendered immutable. And that way, in case there's issue with the primary data, like on your ESX server, or something happens to the performance tier, gets corrupted or encrypted, there's an immutable copy that can be restored quickly. You should also plan for the capacity tier to be sized appropriately to the performance tier. And this is typically a function of retention time, so that'll vary from organization to organization. So why are we talking about MinIO in conjunction with Veeam? For starters, MinIO is widely considered to be the fastest object storage in the world, and that's going to drive those fast restores that you need. Secondly, MinIO is software defined, so like Veeam, that means we run on commodity hardware, so you can cut cost and performance and have them blended as necessary. Third, MinIO was designed to scale through simplicity, the same way the hyperscalers are. So we start with simple blocks, and those can be scaled out infinitely. Finally, MinIO is Kubernetes native, and that's going to provide additional flexibility in deployment of your configurations. And it gives us cloud native integrations like the announcement that we had with VMware on Tuesday. So I won't talk a lot about this slide. You can see some of the benchmark numbers that we have against various configurations. The only things that we want to point out is that you're getting high performance whether you're using hard disk or NVMe, and whether you encrypt the data or not, it's going to be high speed. So what are the things that make MinIO fast? First of all, we only do object storage. So that means we don't have any additional layers, no additional hops, and no artificial friction. We don't employ a metadata database. So all operations are going to be atomic, which really comes into play at scale. We have heard reports of some other metadata databases like Cassandra not being able to hold up at scale. So it's something important to keep note of. We optimize at the hardware level. So we use SIMD acceleration for AVX 512 or AVX 2 on x86 platforms, and we use Neon for ARM. We do a lot of tuning around performance for commodity hardware. So you're not locked into a black box appliance that you don't have access to and that you don't control. And finally, we wrote our application in Go, so that can deliver performance that exceeds C by targeting processes directly to the task at hand. And with that, I'll hand it over to Steve.
Thanks, Echo. So within Veeam, we have what we call our three principal tenants, right? Veeam wants to be simple. We want to make it easy for you to certainly back up your data, but more importantly, we want to make it easy for you to restore the data. Flexibility. As your data grows, as your environment changes, we want to be able to accommodate everything, right? On-prem, off-prem, hybrid cloud, whatever you have, we'll be able to meet those demands. And reliable. Check forms and check some of the, multimedia and stuff. You'll see that there's a, Veeam has a, it just works, right? Customers just say, the thing we love about Veeam is it just works. You install it, set it up, and hands off, let it go. Works wonderfully. And as Echo mentioned earlier, we have this capacity tier that we introduced about a year and a half ago. The capacity tier is an extension of our performance tier, which is typically your high-speed backup target, where you're going to do the majority of your restores from. But we added this capacity tier using the highly scalable and affordable object storage. So what this allowed us to do is, let's say if you were to use the move mode, which I'll explain, you could say, well, I want to keep data on site for 30 days. But then I want to keep, 30 to 90 days, in the object storage. So, this is where we would take the data after it reaches that 31 days, we'll move it over to MinIO, and you can restore it from there. So it's actually a logical extension of our performance tier. And what this does, it allows us to satisfy, the 3-2-1 rule, right? Having 3 copies of your data, 2 of them on different either media or formats. So in this case, it would be, one copy would be block, the other copy would be an object storage. And one of those being offsite or immutable. And so with MinIO, we can take advantage of the immutability factor. And again, we talked about the simplicity and how easy it is to do this. It really is a couple checkboxes, right? First, you would go in and you would select, I want to take advantage of this capacity tier. Click the add button, configure. You give it the MinIO address, the credentials. That's it. And then, as I mentioned, we have the copy mode and we have the move mode, and they can be used simultaneously. The copy mode, as it sounds, it will, as soon as we make a copy to the performance tier, we'll copy that data to the capacity tier. And as I mentioned earlier, the move mode, and this is where you can see the example says 14 days. So we'll keep data in the performance tier for 14 days, and then we're going to move it to the MinIO storage. At the bottom, you can see the encryption, right? So, we typically recommend, or definitely recommend, using some form of encryption. That way, the data, when it's being sent to the MinIO storage, it will be, encrypted. So we talked Echo, sorry.
Yeah, I'll take over the next couple of slides. So this is just what the MinIO deployment looks like. We're running commodity hardware. We're just asking for JBODs. We don't need any complicated RAID underneath. We're as fast as your network. So we always try and saturate the IO subsystems, and that typically comes at the network side. And we deploy either with a single command for bare metal or via the Kubernetes operator. So deployment is incredibly simple. And we do have an Ansible playbook for those who want to do bare metal automation. Going back to the simplicity that we talked about before, here you see our command line utility MC, which is the MinIO client. And all you need to do to make an immutable bucket is just pass this -L flag, and you're ready to go with Veeam and MinIO. Back to you, Steve.
Thanks, Echo. So as Echo showed, is once you create that bucket on MinIO, when you go into Veeam, you're going to find it, and when you're going to check the checkbox there that says enable immutability, we're going to go out and verify that the bucket on MinIO was created with that flag, so that it is immutable. So the two systems have to be in sync, and this is a way to enforce it. So again, very simple. You go in, pick the bucket, pick the folder, turn on immutability, and you're off and ready to go. Now I mentioned that there were the two modes, excuse me, the move and the copy. So how this is done is, you can see in this example, we have our performance tier, and then we have our capacity tier with MinIO. So when I do a backup, so in this case, it's going to be a full backup of a VBK file. So that's what the backup file looks like, right? It has some metadata and a bunch of data chunks in it. So when we go to move it, what we're going to do is we're going to actually we're going to take the data, and we're going to copy it or move it into move mode over to the MinIO along with the metadata. And on the performance tier, we're going to still keep that backup shell, but we're only going to keep the metadata. So this is the way we can prune the data out of the performance tier, which would allow you to increase your ROI on the performance tier and have savings using the MinIO and the capacity tier. So whenever you need to do a restore from the performance tier, Veeam's going to go out and use the metadata to identify where the object is on MinIO and pull that data back. And what that does is, again, it's going to be using our 3-2-1 rule, right? So that's, again, where we're going to have that 3 copies of data, 2 of them on different formats. Again, like I said, block and then on object. And especially if the MinIO environment was in a different site, that would even go further to work on that 3-2-1. And again, that 1 copy being immutable. So as Echo alluded to, when that data is in the immutable state on MinIO, it cannot be touched. It cannot be altered in any way. So this is a great way to keep that data protected from any sort of ransomware. Now, when Veeam goes to do a restore, we have the intelligence that we're going to check in the performance tier first to see what data already exists in the performance tier. So, we're not going to go out to MinIO and pull back all of the data for a particular backup, right? We're going to check first to see if we have any blocks that match, the patterns that are off in MinIO. So that way we're going to pull back as little data as possible off MinIO. So we're going to restore as much as we can off of that, near on-site fast performance tier. So it's a balance of both. We're going to be able to, use what we have locally and well as pull what we need from MinIO. Additionally, we when we released version 10 earlier this year, we added what we call the copy mode. And as I said earlier, that's exactly what it does, right? So when you have a backup file, again, the VBK created on the performance tier, we're actually going to copy over the metadata and the data chunks. So in this case, you are going to have both sites, the performance tier and the capacity tier are going to be in sync. So this way, if you had any sort of an outage or any sort of issue on the performance tier, you're going to have that immediate accessibility to the data within MinIO and the capacity tier. So it's a great way to utilize MinIO as your DR copy. As I said, so what this does is, this will validate that you have at any one time that 2 copies of data on those different disk formats. So, what this is going to do, whenever you have your backup files, your VBKs for the full, VIBs for the incrementals, as well as your metadata, that's all going to be copied now in the copy mode to MinIO. And again, same sort of logic is going to apply. That if you needed to do a restoration, we're going to pull it off of the performance tier first, and then we're going to go and get what we need, if anything, off of MinIO. And that's where you can still use the copy and move mode in conjunction with each other. So this way, if you had both copy and move enabled, what would happen is that when you do your backup on day 1, it's going to make that copy over to MinIO. Using the example of 14 days, after 14 days, we're going to prune the data off of the performance tier. We're not going to have to move anything now over to the capacity tier in MinIO because, well, it was already copied originally. So this is going to give you the best of both worlds, where you're going to be able to have that instant copy to MinIO for the DR purpose. And then you're going to also have the ability to move and prune data off of your performance tier. So it's a great way to provide that protection for a DR or ransomware immediately, as well as cost savings on your performance tier by sending the data to the object storage in MinIO. So not only does the immutability that we use with MinIO protect you from ransomware, it also will protect you from a malicious attack from insiders. And what this does is, so we use compliance mode. So with the S3 object locking, there are 2 modes. There's a compliance mode and a governance mode. Compliance is the higher level, right? I mean, literally nobody can, once you turn this on, you can't turn it off as long as any data in the bucket is, exists with a lock on it. So if somebody, internally got a hold of Veeam and said, well, I'm going to turn off immutability, it's not going to work, right? You can't. You're going to get an error. And let's say you're going to go out and you want to go delete a backup job, right? Well, before I, encrypt their, production data, let me delete all their backups so they can't get anything back. It's not going to happen, right? Veeam's going to go out and say, nope, can't do it. That data is locked. So from within Veeam, you can't do anything to turn off or alter the status of the immutability. Once it's on until all the, the data has expired. And now Echo is going to show us how it works.
Yeah. So I'll switch over to a quick video that we did for a demo of all of this happening. I wanted to talk about the demonstration environment a little bit before we get started. So in this environment, we used 10 gigabit connections between Veeam and ESX and MinIO. So what we're expecting there is that we want to saturate line speed, so that 10 gigabit connection should be about 1 gigabyte per second. We did use NVMe disks for the lab, but that is not required for Veeam and MinIO together. We just did that to ensure cheaply and quickly that disk I/O was not going to be the bottleneck. So we'll start off with just a basic job, same way that you would do with anything in Veeam. Here we're going to back up 10 virtual machines. Each virtual machine is about 12 gigs each. We've already set up MinIO as the capacity tier. So anything, and we've set up copies. So anything that gets put to the performance tier automatically gets copied back to the capacity tier. So you see that we've chosen the sober there to make sure everything gets backed up. So we'll show the job beginning, and then we'll fast forward a little bit to show the stats at the end. So here you can see that the virtual machines finish in about 2 minutes, and the total throughput for the processing rate is 979 megabytes, so pretty close to that 1 gigabyte per second that we're looking. So here, as data gets offloaded to the capacity tier, we see again, as we look at the stats for the job, that the VMs took about 2 minutes each to get put through. And that's aggregate, so it's not 12 minutes total, but it's about 6 minutes for everything. So as Steve talked about, immutable objects can't be deleted. So if I try and delete this VM, it won't work. Keep in mind that if somebody had access to your secret key and access key, they still couldn't delete the object. So the only way for that to happen is if somebody compromised the back end. So if somebody has root access to your servers, you're already in a lot of trouble. So, and here the immutability was set until 12th of October, so it can't be deleted. So what we're going to do here is delete, not delete, but we'll disable the performance tier so that we do this restore of the VMs to ESX, and those VMs will be going directly from MinIO. During this process, we'll show a little bit more about our MC MinIO client, and it has ability to do what's called MC admin trace. So that traces all of the S3 calls that come into the MinIO server. So we'll be able to see Veeam just doing a flood of requests to MinIO. In this case, when we do the restore of the virtual machines, we're going to restore them to a new location with a new name so that we have restored the entire virtual machine, not just a diff. So go ahead and add a suffix to it so it's restored with a new name. Go through the wizard. So here's the HTTP tracing with the MinIO client. You'll just see a massive flood of requests coming through to the MinIO server. So these are all get objects being done in parallel. So great multi-threaded performance. And you can see here the restore rate of the virtual machine is that 1 gigabyte per second. So that's saturating our line speed again like we want. So we do a quick check of the restored VMs. Try and power it on. It's powering on fine, and we'll do a very quick look at the console and see that the virtual machine did power on. So in summary, we want to talk about some key takeaways. The first one is that simplicity is vital. Being software defined, both Veeam and MinIO are a great fit for each other. But you have to put in hard work to make things simple, but making them simple is how you allow them to scale. Second, immutability is critical. It's going to shrink the attack surface, and it's going to protect you against ransomware and malicious users, but it's also going to protect you against honest mistakes and just infrastructure failures. And finally, rapid recovery is the key to getting operations running smoothly. So having agility in your response gets your infrastructure back and running before it actually becomes a problem. So with that, I'll hand over to Jonathan to start taking some questions.
Yeah, thank you. There's some great questions in the chat window. Let me start with Luca's question. Can I make a bucket that is already in use immutable? And how are existing bucket backups managed?
So on the MinIO side, the bucket has to be created immutable at the time of creation. But if you had existing backups in an existing bucket, it is possible to move those to an immutable bucket through that MC client utility so that you can start over with an immutable bucket. Got
it. So there were some questions also about thinking sort of where attack vectors could come from the inside, particularly around admins. So there was a question, can a MinIO admin, in contrast to a Veeam admin, turn off the object lock in compliance mode? And sort of maybe walk us through in general, sort of once that object lock is in place, what are the potential bad outcomes? I think you referenced some of them, but maybe you can go into a little more detail there.
Yeah, so if somebody has admin access to your MinIO instance, they can do anything, just like having root access to anything else. So even if they can't disable the immutability on the bucket, they could still just delete all of the backend data of that bucket. So really you want to make sure that you're protecting against having malicious users as admins. But from the Veeam side and from any application side, you typically are setting that bucket up with IAM permissions. So you have limited access to what the administrator can do. So you can completely disable the ability for them to create a bucket, to delete a bucket, to do anything to it. But just like having root access to any Linux system, if you have root access, you have full control. So limiting who has access to what is just a good best practice in any organization.
Got it. So question in from Quincy: how safe is MinIO to open up to basically internet-facing the internet-facing world?
So by default, we disable public access to all buckets. So there's no chance of you accidentally opening a bucket to the public because we have these IAM roles. Even if access key and secret key is compromised for a given application, they only have access to do what that application can do. So just like any other web-facing application, you're going to want to make sure that you have firewalls in place, that you're denying access from known bad actors and things like that. So it's the same as exposing a web service to anything else. From the MinIO service, attack surface is very small. Our binary is only 40 megabytes and only has key components for object storage. So there's a very small attack surface, and we do regular audits for security on the product. So,
got it. So Wayne was asking, does the MinIO device support MFA?
It does not. Currently, I believe it's been put in as a feature request, but it's not MFA right now, to my knowledge.
Got it. And Luca had a follow-on question. Can I move the data from a simple bucket to an immutable bucket for using the lock on the backups?
I'm talking about from Veeam? So if we are talking about Veeam, then yeah, it's the same that we talked about before. You would have to set up a new sober pointing to this new bucket, but that is pretty much all.
And somebody had asked earlier about just sort of the basic underpinnings, the foundational components of our object locking approach. Can you just talk a little bit about them, object lock, versioning, and the model and so forth?
Yeah, so everything that we do with MinIO is to the S3 spec. So whatever happens in S3, if you're doing any kind of locking or versioning against S3, it works the same way in MinIO. Versioning and locking typically are application driven. You wouldn't normally, as an admin, be worrying about anything with versioning or object locking besides just creating the bucket with the ability to have those features.
Yeah, and there's a fair amount of documentation of that on docs.min.io, and then also in our blog as well as to kind of how that works. Jameer asks, can we perform cross-account admin operations with S3 IAM?
So cross-account, I don't think comes into play with MinIO, but you can have IAM roles defined in MinIO. So the same IAM roles that work inside of S3, it's the same type of model where you create a policy that has the specific API actions that you want to allow, and then you apply that policy to a given user, whether that user is an admin or credentials that you're giving to an application, etc.
Excellent. So talk to us about how many servers are required to deploy MinIO.
So the minimum amount of servers required is 4. If you want to saturate performance, you should be filling those out with enough disks to saturate your network. In larger deployments, you would have obviously more servers. The more servers that you have, the more fault tolerant we are. So by default, you can lose up to half of your MinIO servers and still have read access to them and to all the objects, and you can lose half of your servers plus 1 and still have write access. So if we took an example of a 16-node cluster, I could lose 8 of those nodes entirely and still have read access to the data, and I could lose 7 of those nodes that I have n divided by 2 plus 1, and even if 7 nodes are offline, I still have quorum for writes.
Is there a maximum number of servers that MinIO supports?
There's not a maximum number of servers. You can deploy as many as you want. It is important to keep failure domains in mind. So although it is possible to deploy 1,000 nodes, do you want 1,000 node failure domain? So that is something that each organization will determine on their own. But with dense storage that's available through various vendors, you can get the capacity that you need with smaller amounts of servers. It's easy to get into the petabyte range with just a dozen servers or so.
Got it. Someone was asking sort of what are the types of automation options that are available when you do deploy?
So everything is automated through our Kubernetes operator. We're built to be cloud native from the ground up. So if you're using Kubernetes in your shop already, then that will work just fine. In bare metal, we're a single static binary of that 40 megabytes that I talked about before. So any automation that you can think of, Puppet, Chef, Ansible, is all going to work with very little that you need to do for the setup. And we do maintain official Ansible playbook.
Got it. So speaking of bare metal, this one just came in. Sort of, what are some examples of those kind of bare metal commodity boxes that MinIO runs on?
Yeah. So every organization is typically going to have their own preferred vendor that's given them things that they use in their environment already. So basic boxes like an R740 for maybe some higher performance workloads, down to like HP DL360s for just basic loads. But really it all comes down to if you have the right number of boxes, you can saturate network, and you can't go faster than the network. So,
got it. Any questions for Veeam in the chat room? I don't see anybody, but I want to make sure that we take advantage of Steve's expertise as well. Here's another one. If MinIO does not have a metadata store, how does it keep track of objects?
So the metadata is actually stored as headers in the object. So if you were to stat any given object, you would see things like the e tag, the creation date, things like that. and all of the metadata that we need is just stored in the object, and then that metadata is typically, in the hundreds of bytes or kilobyte range or so. So it's very small for any given object.
Got it. So somebody responded to my question about anything for Veeam, and Quincy writes, "Well, Veeam just works." So fair answer. Fair answer. All right. Well, if there aren't any other questions, I think we will we'll stop here. I think I want to. Here we go. How does bucket policy related to anonymous authorized access?
So those are kind of two conflicting things. Anonymous access is just what it sounds like. It's essentially a public bucket. So you can set up an alias through that MinIO client that allows you to have anonymous access with no secret key. But typically, there's not much need to have a policy on a public bucket, although it probably is possible. I don't think I've seen that use case before, though.
Okay. All right. Well, listen, thank you for all the great questions. We will make, obviously, the slides as well as the recording available to all the registrants. There was one question earlier around, actually, we have a couple more coming in, so maybe we'll answer those. There was a question earlier about performance, and why don't you answer this question while I back up to that slide for you, Echo? So what kind of file format is supported in Veeam at the backup?
So Steve can take that, or I can take it, either one.
Why don't Steve you grab that one?
Well, sure. I mean, as far as the format, I mean, we have, VBK files, which are full backups, VIBs, VRBs. I mean, pretty much all of the typical file backups that you're going to see going, from Veeam to the capacity tier can go to the performance tier, can go to the capacity tier. So if you're asking like what type of file formats, I mean, yeah, fulls, incrementals, reverse.
Yeah, from the MinIO side, we don't care what the content of the object is. We'll store whatever format of whatever exists. If you're talking about what file system should be presented, I believe that Veeam recommends REFS if you have the ability to deploy it. From the MinIO side, we recommend XFS. We do not recommend necessarily things like ZFS, which add complicated layers on top. We don't recommend things like LVM, which will have additional performance impacts. So it can be done, but our recommendation is to keep it simple. Just give us XFS, JBODs, and we'll do the rest. Great.
So Echo, do you just want to talk through, both the distributed numbers and the encrypted numbers, and why we're fast on encryption?
Yeah. Everything, like we talked about, is optimized at the CPU layer using those AVX512 and AVX2 instructions. In any given MinIO deployment, what we're always seeing when we're doing benchmarks or when customers are showing us their numbers is that CPU and RAM are not factors. You're using on 100 gigabit network for full throttle loads, you're using like 30% CPU on pretty modest CPUs. RAM typically resides at about the 64 gigabyte range for that 100 gigabyte connection. We recommend 128 just to give you room to grow in case things changed in the future. But the disk subsystem is what, like making sure that PCI bus is fast enough, disk subsystem is fast enough to saturate the network is what's critical. So these encryption operations really don't play like they would necessarily in other places. And a lot of that specifically because we did those assembly optimizations and the optimizations for AVX512 and AVX2.
Got it. So Brian came in with a question. When deploying MinIO using Kubernetes, if I use a persistent volume plugin that does not support read-write many, is this a bottleneck for parallelizing access to buckets using MinIO?
I'm not sure. So typically what we recommend is just presenting physical volumes. So in that case, it's the same as having access to the underlying disks. So I could see in that situation where it potentially could become a performance bottleneck, but to help mitigate that, we actually have a tool called Warp. So Warp is an S3 benchmarking tool. So in any given workload, in any given environment, you can run those Warp benchmark numbers and verify that you're getting the performance that you're expecting to for any given S3 operation. So deletes, gets, puts, all of those things.
Great, great. One other question here. What's the cluster architecture of MinIO Object Storage Server?
So the easiest way to think about this is erasure coding. So whenever we persist an object, that object gets erasure coded across the servers. By default, that erasure coding we alluded to a little bit before is that n divided by 2, but that can be changed. So I can say in a 16 server cluster, I can specify that 8 of those disks will be used for data, and 4 of those disks will, 12 of those disks will be used for data, and 4 of those disks will be used for parity. And then I have less durability at that point, but I get more usable space. So depending on what your needs are for durability versus capacity, you can set that up. But basically, just think of it, the easiest way to think of it is in a default scenario, I can lose up to half of my servers, and I'm fine. As far as running MinIO against a distributed cluster, you're just running a single command that you set up either through systemd or via Kubernetes. It's already going to be automatic. So you're just running one command on each server, and they handle all of the rest. So there's no complicated cluster setup whatsoever. It's just deploy the servers, format the disks, present them to us with that single command line, and we handle everything else.
Yeah, that's one of the great advantages of 2 software-defined players integrating with each other. Okay. Well, thank you very much for participating today. Like I said, the slides and the recording will be distributed to all registrants, and please enjoy the rest of your day.
Thank you, everyone.